Hello, and welcome to the Dreamy Physicist. I'm so glad you're here. Now, find your breath, slow and soft. Let the world fall quiet around you. Tonight, we begin not with soaring heights, but with silence, not with speed, but with the soft breath before movement. There is a kind of magic in stillness, though it's not the magic of myths or spells. It's the physics of balance, the calm that must come before anything can rise. A bird does not begin with flight. It begins with watching. It waits, wings folded, listening to the air. And you, too, begin here, in this moment of rest, where everything holds and nothing pushes. This is equilibrium, though it doesn't feel like a science word. It feels more like peace. Gravity pulls you gently down. The ground presses you quietly up. And for a moment, everything is equal. Stillness is not the absence of motion. It is the quiet conversation between forces, the soft tension that holds everything in place. It is gravity's lullaby and the earth's embrace. Lie still for a moment longer. Let the muscles in your shoulders loosen. Let the air pass slowly through your nose, cool and rhythmic. You are in the same stillness that every winged creature feels before it leaps into the sky. A glider rests on a hilltop, its frame silent, its wings stretching toward the edge of the wind. It does not move, not yet. It waits, like you do now. This is the beginning of flight, not the motion itself, but the moment before, where possibility gathers, where pressure builds gently beneath intention. Before a wing can rise, it must know the weight it carries. And you, your body lying here, carry your own weight, your own mass. That word, mass, is not something heavy. It is simply the measure of how much of you there is. Your presence, your quiet force. Gravity holds your mass close, not with violence, but with constancy. It pulls the oceans to the shore. It cradles the moon in orbit. It keeps your feet and your thoughts softly tethered. And yet, flight begins with asking, what if I let go? But first, you must learn the rules. A wing is not just a shape. It's an agreement, an understanding between air and surface. A curved top, a flat bottom. A design that listens rather than demands. The air moves faster over the curve, slower underneath. That difference in speed creates a difference in pressure. Less pressure on top, more pressure below. And so, the wing is lifted, not yanked, not hurled, lifted. This is Bernoulli's principle, a quiet truth, not shouted, but whispered across the surface of the sky. You may not feel the air now, but it is here, around you, inside your lungs, slipping through the silence. It is the same air that fills the space between feathers, the same air that streams along the edge of every jet, and the same air that once swirled around the first dreams of flying. Before planes, before paper wings, before engines, humans looked up and watched birds. The albatross, who sails on currents invisible, never flapping, only leaning into the wind. The falcon, who folds its body to dive, falling before rising. And the owl, who glides without a sound, teaching us that not all motion must be loud. What they all knew, and what we would learn, is that stillness is not idleness. It is a gathering of knowledge, a quiet study of the air. The Wright brothers knew this. Before they flew, they observed. They didn't rush into the sky. They built gliders and watched the wind. They studied pressure and angle and force. They let the stillness speak, and when the first aircraft lifted off the ground, just for seconds, it did so because the forces were balanced. Weight was counted by lift. Drag was matched by thrust. But none of it could begin without the stillness you feel now. Let your body become that first wing, soft, curved in thought, perfectly resting. Let gravity hold you, not as an anchor, but as a friend, a steady presence that teaches you how rising works. Because flight is not escape, it is relationship with the air, with pressure, with what came before. You can only fly because something first held you. Even now, as you lie there, feel the ground beneath you, the firm, patient earth, and above, the weightless ceiling of the sky. This space in between, this quiet middle, is where lift begins. The bird perched on a wire feels it. A plane taxiing on the runway knows it. And you, in your own way, rest in it now. Let your thoughts float up like early morning mist before the sun stirs the sky. Let your heart beat slow, as if preparing to leave the ground. Not in a rush, but in wonder. You are not flying yet, but something in you is beginning to understand how it happens. The air does not fight the wing. The wing does not force the air. They meet in motion and agree to rise. It is not a battle. It is a balance. And it begins right here with you. Still breathing, waiting for the moment when the quiet becomes a current. Because very soon, the air will begin to move. And when it does, you will be ready to listen. The stillness has passed. Now, something stirs, not loudly, but like a soft tide, spilling into a once silent room. The air around you, once perfectly still, has begun to move. You don't see it, but you feel it, like the hush before a bird takes flight, or the sudden hush inside a deep breath, held just a moment too long. Air begins to slide. It curls around you. It kisses the shape of things, and then departs, never quite the same. This is flow, and flow is never random. Even wind, as wild as it feels, listens to laws older than language, invisible rules etched into motion by physics. You're not watching from outside. You're inside this movement. Air moves around you and through you. Your breath is part of the pattern. Your skin, your presence. You shape the air, and the air shapes you. Air is a fluid, not just gases in a room, but something that behaves like a silent stream. It bends around objects, curves along edges, and responds to pressure the way water does. Imagine a river. Now imagine the same river, but made of wind. That's how air flows. When you move your hand through it, it parts, not violently, but obediently. The space you make, the speed you move, these determine what kind of flow you create. Move slowly, and the air glides past. In soft, ordered sheets, this is called laminar flow. Like calm dancers, each particle of air keeps to its lane, but move too fast or too rough, and the order breaks. Currents twist, little whirlwinds form. That's turbulent flow, not random, but complex, still lawful, still beautiful. Both kinds exist in the sky. A bird's wing must understand them. Without thinking, your hand in wind must navigate them, even in dreams. Now picture a wing, not moving yet, just poised. The moment it slices into air, everything changes. The flow splits. Some air goes above, some below, but it doesn't travel equally. The top of the wing is curved, so the air above moves faster, and when air speeds up, it thins, loses pressure. The bottom is flatter. Air there moves slower, keeps more pressure, and so pressure above is less than pressure below. And this difference is where lift begins. It's not a push. It's not magic. It's just the air doing what it must to fill the space around a moving wing. But flow isn't just about pressure. It's about sticking. Yes, sticking. Air doesn't always want to stay close to a wing's surface. If it peels away too soon, it creates drag, that backward force that holds things down. But sometimes a little turbulence keeps the air attached. Birds know this. They've shaped their feathers to manage the tiniest swirls at the edge of their wings. A barn owl can fly without a whisper because it understands how to guide flow with silence. Engineers study that. Wind tunnels blow air over models and use smoke to trace invisible paths. They learn where flow clings, where it breaks, where it whispers, and where it roars. They call this study aerodynamics, how things move through air and how air moves around things. And it's not just wings. Even the shape of a bicycle helmet or a racing car depends on the dance of air. If the shape is kind, air flows smoothly, less resistance, less noise, more speed. If the shape is rough, air fights, turbulence grows, and energy is wasted. That fight, that backward grip, is called drag. There are many types of drag, some caused by shape, some by surface texture, some by the weight left behind when air struggles to rejoin itself after parting. But drag isn't always bad. It teaches us what air prefers. It helps us listen to what flow wants. When thrust, the forward force, is greater than drag, movement happens. But too much drag, and flight falters. So engineers shape wings, like poetry, curves that match the air's rhythm. Not too sharp, not too flat, just right to hold the flow and let it pass without struggle. Even in your body, air flows with care through your nostrils, down your throat, into branching tunnels called bronchi. Each split, each curve is designed to guide flow gently to where it's needed most. Nature understands flow. Veins, rivers, breezes, wings, they all obey the same quiet logic. And that logic says, to move through the world, you must first learn how the world moves through you. Tonight, you lie still, but air moves all around. Flow doesn't need your motion. just your shape. Even a leaf resting in air feels the push and pull of passing wind. Even a feather falling dances with the swirl. What you think is stillness is full of motion, and what you think is empty is thick with meaning. As you drift into sleep, imagine the flow. See it wrapping around you like water, like silk, like breath. You are part of the air's journey. You bend it, and it bends you. You are not separate from it. You are written into its lines. And somewhere above, a wing is learning how to rise, not just by moving, but by moving with the flow. The air is already moving. It flows, invisibly, rhythmically, across your face, around your fingers, through the hollow space above your chest. But not every shape can catch it. Some shapes drift, some tumble, some simply fall. And then there are the shapes that rise. Wings are not magic. They are intention made solid. They are geometry tuned to the language of air. They do not fight gravity. They invite the sky to help. Close your eyes and picture a wing. Not just the feathers, not just the outstretched arm of a bird, but the shape in cross-section, a slice, a curve, a story hidden in silhouette. This shape is called an airfoil. It is not symmetrical. The top curves gently, like a smile resting in thought. The bottom is flatter, a quiet path for slower air. The secret is this: the curved top makes the air above move faster, and fast-moving air loses pressure. So while the top flows quickly and thinly, the bottom flows more slowly, pressing up. This difference in pressure creates lift, not by pushing, but by persuading. It's a kind of gentle trick, not deception, but design. The wing doesn't need to flap or beat to create this lift. Even held steady in moving air, its shape does the work. A paper plane, a glider, a kite, all rely on this same quiet truth. Air prefers the path of least resistance, and the right shape shows it the way. You are surrounded by shapes: the curve of a bird's wing, the slender blade of a dragonfly, the outstretched arms of a soaring albatross. And though they differ, they share one lesson. How you shape yourself determines how the world moves around you. In flight, small changes in shape make vast differences. A steeper angle gathers more lift, but also more drag. Shallow tilt slices the air smoothly, but risks too little support. This angle is called the angle of attack, and finding the right one is like tuning a stringed instrument: not too tight, not too loose, too steep, and the air separates from the wing's surface. Lift collapses. This is called stalling, but just right, and you ride the stream. It's not only the wing's shape that matters. It's how that shape meets the air. Birds know this. Even in still air, they tilt their feathers, adjust the twist of their wings, and guide their bodies to match the invisible rivers flowing around them. They've learned what we once had to discover through trial, through falling, through listening to the sky's resistance. The Wright brothers, on a windswept hill in North Carolina, did not simply build engines. They studied wings. In their bicycle shop, they built airfoils and watched how wind slipped around curves. They built wind tunnels before they ever built flight, because the shape must come before the motion. Even a powerful engine cannot lift a poorly shaped wing, and even a bird with broken feathers cannot soar. Lift begins in design. Flight begins in form. You too have shapes inside you. The soft curves of your lungs, the arch of your ribs, the branches of breath that catch the air. Your body knows how to rise, not through flying, but through breathing. Each inhale draws air along smooth passageways, curved and branching, much like a wing. Even your thoughts have shapes, ideas that lift you, emotions that weigh you down, and beliefs that sometimes do both. The physics of flight is not so far from the physics of feeling. Now imagine standing on a hill. The wind moves past you, brisk and invisible. You hold out a small model wing, just a curve of wood or metal or paper. You tilt it slightly. Feel the tug upward. It wants to rise, not because it's light, not because of magic, but because of its shape. It's ready. You can feel it, a kind of readiness in the air itself. That's what flight is. Not forcing, but allowing. The wing becomes part of the air's journey. It guides the flow, splits it gently, reunites it with grace. The air plays no favorites. It offers no guarantees. But with the right shape, with the right attitude, you create conditions where lift becomes possible, where rise is not resisted, but embraced. And that's true, not only for wings, but for lives. When things feel heavy, look at the shape you're carrying. When dreams don't rise, ask what you're offering the air. Are you cutting too sharply? Are you angled too steep? Are you flat to the wind, missing the chance to curve? You are not a bird, but your mind can soar. Your breath can flow. And the way you meet resistance can either drag you down or lift you upward. The air waits for no one, but it is always listening. It presses. It flows. It searches for shapes to rise with. As you lie still, your own shape becomes part of the air story. Even now, you are a surface the air wraps around. And above you, the wings of birds and planes curve and tilt, testing their angle, reading the flow. Not every shape will lift, but some, designed with care, will always want to rise. And in the chapter ahead, you'll feel that rise not just in thought, but in motion. Because the next part of flight isn't about form alone. It's about what happens when shape meets speed. You might think flight begins with power, with the thunder of engines or the flurry of feathers against the open sky. But the truth is gentler. Flight begins with balance, not between motion and stillness, but between the downward pull of the earth and something quiet rising up to meet it. This is lift. You cannot see it. You cannot hold it. Yet it holds you. It is the reason a bird can pause mid-glide. The reason a jet can carry hundreds through thin air. It is not loud. It does not shove. It coaxes. It whispers. Lift is the soft force that forms when air flows across a wing and chooses to help. Imagine this. A wing slices through air. Angle just so, curve just enough. Above the wing, the air speeds up, racing across the longer, rounded surface. Below the wing, the air moves more slowly, sticking close to the flatter bottom. This difference in speed creates a difference in pressure. Faster air above pulls gently, creating a low pressure zone. Slower air below pushes softly upward, where the pressure is slightly higher. And this difference, this imbalance, becomes lift. It doesn't pull the wing into the sky. It relieves it from falling. It eases its burden. It is not a thrust against gravity, but an invitation to float. You have felt lift before, not with wings, but with your breath. On a cold morning, when you breathe in deeply, you feel your chest rise, your ribs expand, not with effort, but with openness. That is lift. The wing does not force the air. It shapes itself so the air can do what it already wants to do: flow, move, balance. Even in something as mighty as an airplane, lift does not come from pushing the sky downward. It comes from gently making the sky want to hold it up. Now imagine you're lying in a field. You see a hawk far above, circling, gliding. Its wings barely move. It floats, suspended, not because it is weightless, but because the forces on it are even. Lift equals weight. Balance is perfect. This is called steady flight, and it is not easy. It is the art of staying in just the right position, at just the right angle, with just enough speed to keep lift and gravity in constant quiet conversation. And when the hawk turns, tilting one wing, angling just slightly, it banks. Lift tilts too, and the bird turns, not with force, but with grace. Planes do this as well, by adjusting wing flaps, called ailerons. They change how much lift one wing generates compared to the other. It is a dance of soft pressure, angled motion, and invisible currents. And yet, lift is not permanent. Lose too much speed, or tilt too steeply, and you fall. Because lift depends on movement. It is born of flowing air. Without motion, air has nothing to press against, nothing to shape, nothing to lift. Stillness, on its own, does not rise. There's a lesson in that. Sometimes, in your own life, you must move forward to feel lifted, even if gently, even if slowly, because motion awakens support, and shape determines how that support arrives. There are four forces in every flight. Lift pulls upward, weight pulls downward, thrust drives forward, drag resists behind, and between them is the moment of flight when lift and weight find temporary peace. Lift doesn't always win. It doesn't have to. It just has to be enough. Enough to hold, enough to balance, enough to pause in the fall. Even a feather, dropped gently, finds a bit of lift in the air that moves around it. The wider it is, the slower it falls, because more surface means more air to catch. Wings stretch wide to find that surface, and so do dreams. The broader your reach, the more the world can press upward, not to carry you, but to meet you. Pilots speak of angle of attack, the angle at which the wing meets the oncoming air. Not too steep, not too shallow, just right for the air to part smoothly and reunite in harmony. If the angle's too sharp, air can't follow the wing. It breaks away. Lift vanishes. The aircraft stalls, not because it stopped moving, but because it lost balance. There's a soft metaphor here. When you move into resistance too sharply, when you force too much at once, you lose flow. But if you tilt gently, shape yourself with patience, the world bends around you, and lift finds you. The softness of lift belies its strength. It can carry gliders across oceans. It can let albatrosses soar for hours without flapping a wing. It can lift cargo planes filled with steel because the air does not care about weight, only shape and motion. And the air is always there, all around you, above you, within you, waiting, listening, looking for shapes to lift. Not everything rises, and not forever. But while the air flows, while the wings are shaped just right, while the motion continues, lift can hold you. The soft force, the quiet strength, the invisible hand that doesn't push, but cradles. Even now, as you lie here, your own breath flows in patterns. Your chest rises with each inhale, not from force, but from openness. You shape your breath, and it shapes you, like a wing in air, like a whisper in wind. And as we drift onward, past lift's gentle balance, we begin to notice something else. The wind pushes back. No flight is free. Where there is lift, there is also drag. And to understand how we stay aloft, we must feel the weight of what resists us. Before there were airplanes, there were birds. And before birds, there were quiet, gliding shapes in ancient skies. Creatures testing wind with bone and stretch, feeling for lift, long before we knew how to measure it. And now, when you look at a wing, sleek and metal, buzzing through clouds, you might think it's purely machine, but it isn't. Wings remember birds. You can see it in the way they curve, a quiet upturn. On the trailing edge, camber designed to coax ear into soft, upward work. You can see it in how they stretch wide, long and thin, like a glider, or short and sturdy, like a hawk riding thermals on a summer day. These aren't just design choices. They're echoes of evolution. A bird's wing is not just a limb. It's a story, told in feather, tendon, and bone. And every airplane, in its silent reach for flight, borrows from that story. It starts with shape. Bird wings taper. So do plane wings. This shape, called an airfoil, lets air move more quickly over the top, slower beneath, creating the pressure difference that gives rise to lift. Birds do this without knowing equations. They move by memory, by muscle, by feel. The airfoil shape was born in feathers long before it was forged in aluminum. You've likely watched a bird take off. It doesn't sprint forward endlessly. It leaps, flaps hard, angles into the wind, and trusts. Trusts that the air will answer. Trusts that its wings will remember what thousands of generations have learned: how to fly. Airplanes, too, must trust the air. Pilots speak of airspeed, of angle of attack, of stall and glide ratio. But beneath all of it is the same conversation birds have had since long before speech. Is the air moving fast enough? Am I shaped the right way? Can I rise? Birds have answers in their bodies. Planes have them in instruments. But the question remains the same. Think of the albatross, great wings stretching over 10 feet wide. It barely flaps. It doesn't need to. It reads the sea breeze, finds invisible rivers in the sky, and rides. It is the master of dynamic soaring, using shifts in wind to gain energy without effort. Engineers study this. They map its path. They try to copy it, because the bird already knows what the wing remembers. Or consider the swift, small, fast, tireless. It spends most of its life in the air, sleeping mid-glide, drinking raindrops in flight, even mating mid-air. Its wings are swept and sharply angled, perfect for agility. Jet fighters mimic this. Sleek, darting designs, born from the physics. Swifts understood first. Form follows function, but in the sky, form follows bird. Even in the cockpit, names echo nature. Flaps, spoilers, slats, not machine words, but movement words, wing words. Birds do this all the time. Watch a hawk landing, spreading its feathers like fingers, spilling lift, increasing drag, tilting the nose upward as it slows. It stalls on purpose, settling softly onto a branch. Pilots mimic this too. As a plane approaches landing, it extends its flaps, tilts its nose, spills speed, and trusts gravity to do the rest. We call it flare, the final gesture before touch. Just like the hawk, because wings remember, and engineers remember birds. The Wright brothers watched pigeons, studied gulls. They built their first glider after hours of watching birds arc over sand dunes. At Kitty Hawk, their early designs had wingtips that warped just like a bird's feathers flex to steer or balance. Even now, in advanced flight systems, we return to this flexibility. Morphing wings, designed to change shape midair, are inspired directly by how birds adapt in flight. Because while a plane must fly at high speed to stay aloft, a bird can slow down, hover, pivot, land on a wire with impossible grace. We study them to learn what we forgot. And then there are feathers, not just beautiful, not just warm. Feathers create slots, tiny channels that guide air smoothly over the wing, even at steep angles. This prevents stalling. Modern wings now use leading-edge slats to copy that effect, allowing airliners to fly slower without falling. Feathers knew first. Even the tail has its echo. Birds use their tails for steering, for braking, for lift. Planes use horizontal stabilizers, flat surfaces that pitch the nose up or down to keep balance. An artificial tail doing what the real ones once did. And though planes now have engines, metal, glass, electronics, the core of their flight is still feathered in memory, still shaped by creatures who trusted the air enough to leap from a branch into sky. And so when you fly, when you sit by the window and feel the hum of takeoff, the soft upward tilt, the sudden lightness, you are joining a tradition of wings, a lineage not just of machines, but of animals and instincts and moments of courage. You're part of that, not separate from it. Every flight is a remembering, a way of saying, I feel the sky, I understand the lift, I carry the shape of something older than engines. And when you land, soft wheels on warm runway, you return, not from a machine's journey, but from a long, shared story between bird and wing. But flight, as graceful as it seems, does not come freely. For everything that lifts, something resists. The air does not only support, it pushes back. And as we move forward, you'll come to feel this quieter force, the invisible tug that holds us back just enough to teach us how to keep flying. The sky, though it looks empty, is not still. It holds itself like a quiet ocean, pressing, resisting, wrapping itself around every shape that dares to move through it. And yet, somewhere in that hush, something begins to push. That first ripple, that first defiance of drag, of inertia, of rest. This is thrust. The thrust that breaks the silence. You feel it when a plane begins to roll. That steady build from stillness to sound, from waiting to becoming. At first, it's only a hum beneath your feet, then a tremble, then a roar, not angry, but determined, the kind of promise. We are going. But where does thrust come from? It begins, not in the sky, but deep in engines. Engines are hearts, not of flesh, but of fire. Even the earliest flyers knew they needed something to move them forward. Not just shape, not just lift, but motion. The Wright brothers used propellers, twin wooden spirals, carved by hand. They twisted air into backward wind, which gave the machine a forward pull. Today, we use turbines, jets, rockets, electric fans, but all of them do the same thing. They move air backward so the aircraft can move forward. Newton's third law, a truth so simple, so deep, it feels almost like a whisper. Every action has an equal and opposite reaction. To move forward, something must be pushed back. That's thrust. Jet engines do this by compressing air, mixing it with fuel, igniting it, and letting the expanding gases rush out the back with astonishing force. The result? Forward surge, a breaking of equilibrium, a steady push against drag, against stillness, against gravity's hush. But thrust is not violent, not truly. It is focused, deliberate, a wind shaped by fire. You might imagine it as a long exhale from a machine with somewhere to go. And what a marvel that is. Inside every engine, thousands of tiny blades spin faster than thought, compressing, burning, releasing, each stage like a breath, each breath like a song. It happens so fast, so precisely, you could miss the miracle entirely if you weren't listening. But the sky knows. The sky feels the disruption of stillness. It parts before the thrust, not in surrender, but in dance. Because thrust doesn't only move the plane, it calls the air into motion, and motion is life. There's something poetic about the fact that to rise, we must push against what holds us. Birds do this too. They beat their wings, stroke after stroke, pushing air downward and backward to go forward and up. The air resists them as it resists us, but they persist, and so do we. That's thrust, a kind of resolve. And like all resolve, it needs energy. Energy is the cost of breaking silence. Fuel must be burned. Batteries must be drained. Momentum must be earned. There is no free flight, only gifted moments after long work. But oh, the beauty of it, the way a airplane gathers speed on the runway, not in panic, but in rhythm, faster, faster, until the wings feel what they've been waiting for, until the lift matches the weight, until the drag is overcome. And then a hush again, but a different hush, not the silence of waiting, but the silence of ascent. You are airborne, but you are not done. For us must continue. Even in flight, you are always pushing, not just to rise, but to stay forward. Drag never leaves. Gravity never sleeps. The sky is not a place you own. It's a place you borrow with energy, and energy must be fed. Jet engines spin, props twist, fuel burns. The quiet is broken so that movement can continue, but not all thrust is loud. In space, rockets push with no air to grip. Still they fly, expelling mass to gain motion. In newer aircraft, electric motors whisper instead of roar. Thrust can be many things, but always it is a promise to keep going. You, too, generate thrust in your life. Moments where you push against the heavy air of doubt, of hesitation, of fear. You move forward by deciding to move. It is no small thing to begin, to break the stillness, to leave the runway. And like the aircraft, once you rise, you still must push, still must trust your source of power. The sky does not carry you for free. It demands presence, purpose, continuation. That is the truth of thrust. It's not just a force, it's a choice. And now, as you look out into the distance, where the clouds stretch and shimmer, where the light changes from silver to gold to indigo, remember, every mile you travel begins with that first push, that engine hum, that fire turned forward, that trust in motion. Because only with thrust can lift become more than theory. Only with thrust can a dream leave the ground. But as you soar, as the nose tilts gently upward, as altitude rises and the air thins, you'll come to feel something new. Force. You cannot see, but must always balance. Not pushing, not lifting, but holding. The force that answers motion with restraint. The sky, for all its openness, has rules. And one of them is this: If you move through it, you must pay a price. That price is called drag. You don't see it, you don't hear it, but it's always there, pressing, pulling, whispering back against every step you try to take. Imagine you are walking into the wind, not a violent wind, just steady, insistent. It doesn't knock you down, it simply asks you to try harder. That's drag. It's the air wrapping around you, clinging to your shape, slowing your forward motion. Even when you soar at thousands of feet, even when you feel as though you're flying through a dream, drag is there. Gentle hands pressing on your wings, your nose, your tail, saying, not so fast. But it's not a punishment. It's a teacher. It shows you what isn't smooth, what could be better, what part of your shape is too rough, too sharp, too wide. In flight, drag is the force you always fight, but never truly escape. There are four main kinds of this invisible enemy. Let me walk you through them, like shadows moving beneath the wings. Parasite drag is the simplest. Air bumping into the plane, slowing it down just because it's there. It doesn't care about your purpose, only your presence. Every bolt, every antenna, every landing gear that sticks out adds to parasite drag. Even the smoothest surfaces still stir the air. Then comes form drag, which is about your shape. Think of the difference between pushing a spoon through water versus a plate. The more blunt your shape, the more resistance you meet. This is why aircraft look like teardrops, long, tapered, curved, just so. The sky loves smooth endings. It detests sudden stops. Skin friction drag is quieter, more intimate. It's the thin layer of air that sticks to the very surface of the plane. Even polished metal isn't truly smooth. At the microscopic level, it's full of tiny bumps and valleys. Air flows over these imperfections, and in doing so, it resists. Finally, there's induced drag, the strangest of all. It's the drag you get from lift itself. Yes, even lift, the very force that helps you rise, comes with a cost. When wings generate lift, they bend the air, pulling it downward to go upward. But this bending creates swirling vortices at the wingtips, tiny tornadoes that trail behind, stealing energy. Induced drag reminds us nothing comes free. Even grace has effort behind it. So why talk of drag at all? Because to understand flight, you must understand what holds you back. Drag is the ever-present resistance that shapes everything. It's why planes look the way they do, why engines must be strong, why designers study airflow like monks study silence. They sculpt the aircraft to slip through the sky with as little protest as possible. Every angle, every contour, every panel has a purpose: to persuade the air not to resist so much. And yet, resistance never vanishes. It can only be minimized. This is true in flight and in life. You move forward and you feel the unseen weight pushing back, not enough to stop you, but enough to ask if you really want it. Drag is doubt. Drag is hesitation. Drag is the force that asks, "Are you sure?" And the only answer is to keep going. Pilots know this. They feel it in the throttle, in the way the aircraft leans, how speed fades when power fades. They trim their planes, adjust their speeds, watch for stall. They learn how to fly efficiently, not just forcefully, because more thrust isn't always the answer. Sometimes the answer is better design, more understanding, less waste, a smoother path through invisible resistance. In the hush of high altitude, you might think drag disappears. But even at 35,000 feet, with thinner air, it still waits. Quieter, but present. It is always there, in the background, whispering softly, "Keep your shape clean. Keep your path straight. Keep refining." And that, perhaps, is drag's secret gift. It doesn't just slow you, it sharpens you. It teaches you to listen to flow, to design with grace, to fly with awareness. Without drag, we wouldn't understand the cost of flight. We'd never know how hard the air works to keep us honest, because when you slip through air too quickly, too carelessly, you leave chaos behind. Turbulence, noise, loss of control. But when you respect the air, when you shape yourself to meet it, not with force, but with harmony, then you move forward with less struggle. And isn't that a kind of wisdom? You learn to flow with the wind, not just push against it, to listen to the sky as much as you speak to it. Drag, then, is not just an enemy, it is a mirror. It shows you where you stir things too much, where you are too rough, where you still need smoothing. And so, you fly not to defeat it, but to learn from it, to make every curve more elegant, every edge more kind. And as you fly, as you pass through this invisible sea of motion, you'll find a kind of balance between force and grace, between power and peace. Because in the end, the goal is not to overpower the sky, but to move through it without leaving a scar. And when you begin to learn how drag shapes flight, you'll start to notice another kind of challenge, one that doesn't pull you back, but pulls you down. You don't need an engine to move through the sky. Not always. Sometimes the sky will carry you if you know how to listen. This is the secret of gliding, a quiet pact between the earth below and the air all around. It is not powered flight. It is balanced falling, slow surrender. That becomes a kind of flight all its own. Close your eyes and picture a bird on the edge of a cliff, wings outstretched, no flapping, no struggle. It leans forward and drops, but not downward, not directly. Instead, it carves its way into the sky, held not by effort, but by grace. This is the miracle of a glide. To glide is to move forward as you fall, to let gravity pull you down, while your wings turn that fall into distance. It is the transformation of descent into elegance, and all of it depends on balance. There are only two major forces at play here: lift and gravity. Lift tries to hold you up. Gravity pulls you down. When thrust is gone, when engines sleep, Then the dance becomes a quiet negotiation between these two forces. As you descend, you pick up speed. As you pick up speed, your wings catch the air. And as they catch the air, they generate lift just enough to keep your fall from becoming a plunge. It is not a battle. It is a conversation. A glider has no engine, no roar, no push. It flies only because its wings are long and its shape is right. It trades altitude for motion. Height becomes distance. That is the essential idea. You give up one thing to gain another. Lose altitude, gain range, fall forward, not just down. A well-designed glider can travel dozens of miles from just a single mile of descent. That is the quiet genius of its shape, long wings, narrow body, smooth surfaces that part the air without complaint. And this principle that you can move forward by falling carefully applies to more than flight. It is a kind of wisdom. Sometimes you don't need to resist what pulls you down. Sometimes you use it. You shape yourself in such a way that even gravity becomes your partner. The albatross knows this. With wings like stretched silk and a patience built for oceans, it glides for hours without flapping once. It rides the wind that rises off the waves, tilting its wings to catch the upward drafts, rising, falling, rising again, without ever needing to push. It is not defying gravity, it is dancing with it. So too do sailplanes, the gliders built by humans. They seek out warm air, thermals, rising columns that lift them back upward. A pilot feels the shift, the faint tug beneath the wings, and circles gently, climbing without power. In this way, a glider can stay aloft for hours, carried by nothing but sun, warmed air, and patient design. And even when no thermals come, still it moves, still it falls with grace, still it glides. But gliding is not just an art for those without engines. Even the fastest jets must glide when engines fail. Pilots train for this, calculating their glide ratios, their angles, their emergency paths, because the air will always offer a final chance to land with dignity if you know how to ask. The glide is your last quiet hope when everything else goes silent. It's also a test of how well you understood flight in the first place, because true flight isn't only about power. It's about balance, about using what you have wisely, about knowing when to hold on and when to let gravity help you forward. Even falling can be beautiful when it's done with care. And there's a moment, if you ever ride in a glider, where the tow plane lets go, where the rope disconnects, where the engine sound fades, where silence settles around you like a blanket. It's just you, the air, and the long breath of a sky that agrees to carry you a little farther. No buttons to push, no levers to pull, just the tilt of your wings, the weight of your decisions, and the soft whisper of wind across the canopy. And in that quiet, you feel a kind of peace, because you are no longer forcing motion. You are shaping it. guiding it, trusting that you can fall without fear, that you can let go without losing control. This, too, is flight, not just the roar and the climb, but the gentle glide that follows. And sometimes the glide is the most beautiful part. It is a reminder that you don't always need to fight, that letting go is not always failing, that descent can be wise when you choose its path. Feather gliding to the ground is not a sign of weakness. It is a sign of balance, of surrender, yes, but not collapse. The bird still chooses its angle. The plane still aims its nose. The pilot still flies, even in the fall, especially in the fall. And in life, perhaps this lesson lingers, that when things pull us down, we can still move forward with the right shape, the right posture, the right trust in the air around us. Because falling isn't always the end. Sometimes it's how you reach what's next. And as the ground nears, as the glide begins to slow, there is one final moment, a moment of meeting between flight and earth, between motion and stillness. It's called the landing. And two is an art, but landing, gentle and true, requires another kind of mastery. You may think that wings simply push against the sky, but that's not how flight begins. Wings are not hammers. They are not fists. They do not beat the air into submission. No, a wing is more like a question, softly asked, cleverly shaped. It speaks to the wind in passing, and the wind, curious, answers. This chapter is about that conversation, about the secret that lives inside every wing. It begins with something so simple you've likely forgotten it. Air moves, not just in storms, or gusts, or breezes that play with your hair. Even when everything seems still, the molecules around you are dancing, tiny, invisible, but always in motion. And when something like a wing passes through that sea of air, it doesn't only push against it, it also invites it to flow. And that flow, that smooth, careful movement of air around shape, is where lift is born. Now pause. Picture a bird's wing in mid-flight, or the smooth arc of an airplane's wing as it slices forward. Through blue, you'll notice a curve. The top of the wing is rounded, arched like the back of a cupped hand. The bottom, flatter, more direct. This isn't an accident. This curve, this asymmetry, creates a secret difference. As air meets the wing, it splits. Some flows above, some flows below. But the air above has a longer path to travel. It curves over the rounder top, stretching farther than the air beneath. And because air is restless, it wants to rejoin itself quickly. So it speeds up over the top, and faster air creates lower pressure. This is Bernoulli's principle, named for a quiet thinker who watched birds and flowing water and saw the rhythm beneath their grace. Lower pressure above, higher pressure below. The result? Lift. The wing rises, not because it pushes up, but because the air above it pulls it there, not by force, but by invitation. It is one of the most elegant truths in physics. And yet, it's only part of the story, because airflow is not a single idea. It's a dance of many steps. The shape of the wing not only changes pressure, it also changes direction. As air flows off the trailing edge, it's bent downward. This downward deflection creates an upward reaction, an echo of Newton's third law. For every action, an equal and opposite reaction. The wing presses the air down. The air presses the wing up. So now, lift is not just a pressure difference. It's a collaboration. The curvature shapes pressure. The angle deflects flow. Together, they make flight. And still, there's more. Because a wing is not static. It tilts. Slightly, subtly. This is called the angle of attack. Even a small change in this angle can transform the behavior of air across the surface. Tilt too far, and the air loses grip. It separates. Turbulence forms. Lift fades. Stall begins. So a wing must know its limits. It must be bold enough to cut the air, but not so bold that the air turns chaotic. It must be brave, but smooth, confident, but not aggressive. That is the secret. Inside its shape, a balance, a wisdom. Every wing, from every glider, every hawk, every paper plane, has made this agreement with pressure, with flow, with angles and patience. It is a delicate harmony, and that's why engineers study wings like poets study verses. Every tiny curve affects the way the air behaves, the thickness, the camber, the length of the chord line, an invisible line from the front of the wing to the back, the smoothness of the surface, the twist at the tip, even the tiny vortices that trail off the wingtips tell a story. They whisper about energy lost, lift created, drag endured. In fact, some wings curve upward at the ends. Winglets, they're called, to tame those spirals, to let the glide last longer, to hold the air just a little more gently. Nothing is wasted. Everything has purpose. Even the hum of air past metal contains memory. Some wings are built for speed, thin and sharp. Some are built for soaring, long and slow. But all of them keep the same promise. They will lift if shaped just right, not by brute force, not by engines alone, but by the quiet magic of pressure and flow, of curves and questions. And inside that lift, inside the wing's secret, is something deeper still, an idea that might carry beyond physics, that movement does not always require struggle, that progress can come from listening, that rising can happen when the world around you wants to carry you, if only you give it the right shape to hold. It's not only wings that do this. Ideas can do it too. They can lift when their shape meets the moment just right, when they flow through the world without resistance, when they curve not to dominate, but to harmonize. You, too, have your own wings, your thoughts, your choices, your designs for moving through this life. And maybe You don't always need to force your way forward. Maybe you can glide sometimes. Tilt gently, shape wisely, listen to the flow. Let the world help you rise. That's the lesson. Hidden inside every quiet flight, inside every soaring bird, every drifting seed, every whisper of air over a curved surface, even a paper airplane, molded by a child, carries this truth. Shape matters, balance matters, flow matters, and through all of it, you're not pushing the sky away. You're letting it pull you close. Because the sky, you see, isn't resisting you. It's just waiting for the right shape to carry. And once you understand that, once you really feel what a wing is doing, then you're ready for something faster, louder, bolder. You may feel, as the plane lifts and the ground drifts away, that gravity has lost, that the earth's hand has slipped from your ankle. That flight is freedom from pull. But gravity is not so easily left behind. Even here, miles above cities, above rivers and roads, the earth still holds you. It pulls not with malice, not with chains, but with the simple truth of mass, of presence, of being. Gravity is the invitation. Everything extends to everything else. You have mass. The earth has mass. And so, you attract, even when you fly, especially when you fly. Because flight is not about escaping gravity. It's about balancing it, meeting its pull with another force, just strong enough to pause the fall. Every second, you are in the air. You are falling, but also you are being lifted. And between those two truths is the miracle of flight. Gravity, as gentle as it is relentless, never stops pulling you home. It is the reason wings must shape the air. The reason for us must keep flowing. The reason drag must be overcome. All these forces exist because gravity never lets go. It is not an enemy. It is a rhythm, tide, that must be met with motion. Without gravity, wings wouldn't need to lift. Thrust wouldn't matter. Drag wouldn't slow. Without gravity, there would be no flight, only drifting. So strange that the very force you seek to overcome is the same force that defines the journey. You fly, not in spite of it, but because of it. Picture the arc of a paper airplane thrown across a room. At first, it rises, a breath of hope. Then, slowly, inevitably, it curves downward. Gravity was there the whole time. The plane's shape, its speed, its angle, these only determine how long the fall is delayed, how graceful the descent becomes. Now scale that up. Think of a glider catching a warm thermal, a rising bubble of air, warmed by sunlight. The glider rises, but not because it escapes gravity. It simply borrows a rising wind. It still weighs the same. It still feels the earth's call. But now, it uses the air's upward push to fall. Slower, always falling, but also soaring. That's the secret. Flight is not an escape. It is a surrender to the pull with grace. Even in orbit, astronauts feel this truth. They are not beyond gravity. They are falling fast, sideways, so fast, in fact, that as they fall, the earth curves away beneath them at the same rate. They circle the planet, not because they have left its grip, but because they keep missing the ground. This is orbit, falling forever, but never landing. So gravity is not something you beat. It is something you dance with. And it is always there, in your legs, when you rise from a chair, in your arms, as you stretch upward, in the ache of standing too long, in the sweetness of lying down. It reminds you that you belong to Earth, and Earth belongs to you, that your feet were shaped for its soil, that your lungs were made for the weight of its air, that even in flight, your heart pulls toward home. This pull is more than physics. It is comfort, continuity, a truth you can trust. No matter where you go, no matter how high, you are always connected to where you came from. So as you fly, in dreams or in planes, remember, gravity is still with you. It whispers in the wings lift. It hums in the engines roar. It shapes the very need for flight. And this makes flying even more beautiful because it is not defiance. It is balance. You rise not because you are free from the earth, but because you've learned how to live in harmony with its pull. And gravity is patient. It waits. It pulls gently, tenderly, even when you are thousands of meters high. It does not rush. It does not chase. It simply is. Like the beat of a slow drum, it grounds you even in the sky. So what does this mean for us? It means that the forces we resist may be the same ones that shape our path, that limitations can be scaffolding, that falling can be graceful if met with the right motion. It means we don't need to escape everything that holds us. Some things hold us because we are meant to return, because we are not made to drift endlessly. We are made to move in arcs, to rise and fall, to learn and land, to fly, and then, someday, to come home. Even the longest flights end in landing. The soft kiss of wheels against runway, the gentle tilt forward, the body settling, a reunion with gravity, not a failure, but a fulfillment. You flew, and now you return, and still you remember the sky. Your body, though grounded, remembers what it was to rise, to lift, to glide, to be held by moving air, but never free of gravity, only balanced against it. And as you reflect on this quiet truth, that even in the height of flight, you are still tethered, you might begin to wonder if gravity holds us with such quiet strength. What does it take to move forward through the air? What invisible hand pushes us beyond lift? What force makes motion out of stillness? Because even a wing, perfect in its shape, cannot rise without something more. Long before steel, long before speed, there was only the sky and the longing to reach it. You feel it, don't you? That quiet hunger in the chest, like a door just slightly ajar. A whisper from above that says, "Come closer." In every culture, on every continent, humans looked upward and imagined leaving the earth. They watched birds and envied their simplicity, how easily a sparrow moves between rooftops, how hawks rest on columns of invisible wind. The air, to birds, was a place. To us, it was a mystery. And still, we yearned, long before we understood lift, or thrust, or drag. There was only awe. We saw wings and believed they were enough. So we built our first wings, not with science, but with story. In ancient Greece, there was Icarus, the boy who dared to fly. His father, Daedalus, crafted wings from wax and feathers. They escaped their prison, not by walking, but by becoming birds. But Icarus flew too close to the sun. The wax melted, the wings unraveled, and the sea took him back. A warning, perhaps, but also tribute to the first idea that we might rise. In China, centuries before the rites, records tell of men strapping kites to their arms, leaping from towers. Some fell, some floated, none truly flew, but all tried. In Abbasid Baghdad, a man named Abbas ibn Firnas wrapped himself in wings and leapt from a high place. For a moment, a breath, he glided. Then he crashed. But witnesses said he slowed the fall, that his wings almost worked. It was a beginning. And in the notebooks of Leonardo da Vinci, centuries later, we see sketches, parachutes, ornithopters, machines with flapping wings, and curved canopies. He watched birds carefully. He studied their joints, their feathers, their rhythm, and he dreamed. Da Vinci never flew, but his drawings were filled with questions. What shape holds the air? How do wings fold and unfold? What happens when a current passes over a curve? He was listening to the sky before we had the words. And so it began, this long, slow conversation between humans and the wind. At first, our wings were copies. We thought if we could mimic birds, we would become them. But birds are not just wings. They are balance, hollow bones, air sacs, instinct. We had none of these. We were heavier, clumsier, ground-bound. Still, we tried. 1,000 falls, 1,000 hopes. A man in 11th century England built gliding wings from wood and cloth. He leapt, he floated, he broke both legs, but he lived. And with each fall, we learned something. How to angle a wing, how to balance weight, how to use wind, not fight it. We began to realize flight is not just about wings. It's about the body, the motion, the moment before the fall, and the willingness to fall over and over until something changes. These first wings were not successes in the way we often measure, but they were deeply human. They were made of belief, not just in the sky, but in ourselves. Because every time a person climbed a tower with feathers tied to their arms, they were declaring something, that we are not only creatures of dirt and stone, that the soul, whatever it is, wants to lift, even when the body is heavy. even when the world says no. The first wings were not about height, they were about hope. They taught us to see air, not as emptiness, but as substance, as something to work with, to lean into, to trust. And with time, we began to learn its language, not just from stories, but from the wind itself. We studied birds more closely. We watched how eagles tuck their wings in a dive, how swallows twist mid-flight, how albatrosses glide without flapping for hours. We stopped copying. We started listening. The shape of wings changed. They grew longer, more curved, more rigid. They stopped trying to flap. Instead, they began to hold the air, to catch it, shape it, bend it, to use it not like a bird, but like a tool. And something shifted. Flight stopped being a myth. It became a question of balance, of lift, of force, of design. But in all of this, we carried the spirit of those early dreamers, of the man who leapt from the cliff with wooden wings, of the boy who flew too high and touched the sun. We carried their willingness to try and their love for what lies above, because wings are more than machines. They are mirrors. They reflect what we want most: freedom, motion, possibility, and perhaps perspective. To rise above the ordinary, to see the world from a quieter height. Even now, in a jet with screens and engines and science all around, a part of you still remembers the feeling of strapping on feathers, of running to the edge, of hoping the air will catch you. So next time you fly, really fly, look down and remember the first wings. They didn't take us far, but they took us forward. They showed us that flight is not about ease. It is about courage, not about power, but grace. And though the sky is now filled with planes, satellites, and whispers from Mars, somewhere in that blue silence still floats the memory of the first human wings. And maybe that's where we find ourselves now. Not in escape, but in return. Not in steel, but in story. Not in speed, but in wonder. And just beyond that wonder, a new question forms. If our first wings were shaped by longing, what shapes the engine's first breath? You've seen it, even if you didn't know what you were seeing. A gull hovers over the sea, motionless but suspended. A breeze rises, and the bird shifts, not flapping, just tilting. A fingertip of wind slides beneath its wing, and for a breath, the bird becomes airborne poetry. This is flight in slow motion, not just speed and force, but flow. Motion, so quiet, so smooth, you might think it's still, but the air is always moving. And tonight, we pause with it. We slow it all down. The feathers, the pressure, the rise. Because flight, at its core, is not about violence against gravity. It's about agreement, a negotiation between body and sky. Let's begin at the surface of a wing. Not the whole thing, just a sliver. Run your fingers across it in your mind. It's not flat. It's curved. This curve is no accident. It's called an airfoil, and it's designed to change the way air moves. Now imagine the wind approaching this wing. Fast forward a gust to just one thread, one line of air. Watch it split at the front edge of the wing. Part goes over the top, part flows underneath, but the air on top has farther to travel, so it speeds up, and when air speeds up, it drops in pressure above the wing. Less pressure. Below. More. This difference, invisible, instantaneous, is what lifts the wing. It's not magic. It's not brute force. It's persuasion. The wing whispers to the wind, follow me, bend with me, become something new. And the air listens. This principle has a name, Bernoulli's principle, but don't worry about names tonight. Worry about the shape, the way air flows, like water, around a rock, curling, swirling, reforming. When slowed down enough, even turbulence becomes elegant. Little swirls, trailing the wing, vortices spinning away like ghost threads. In wind tunnels, scientists watch these dances with colored smoke. They light the air so it becomes visible, so we can see what was always there. In those tunnels, air slows down so we can watch it think, how it responds to slope, to speed, to the tilt of a wing. This is called angle of attack, the angle at which a wing meets the air. Slight changes cause big effects. A steeper angle, more lift, until it stalls. Yes, even wings can try too hard. There's a point where flow breaks, where the smooth stream becomes chaos. This is called stall, not a fall, but a refusal. The air stops cooperating. The wing is no longer persuasive, and the sky lets it drop. But if you watch carefully, frame by frame, you'll see the stall arrive like a slow shiver, not sudden, but creeping. Flight, then, is a balance between push and patience, between reaching higher and staying connected to the flow. This is why birds rarely stall. They feel the air with their feathers. Tiny nerves sense the smallest ripple. They adjust before the failure, because to them, air is not just space. It's texture, it's presence, it's partnership. Some birds, like owls, have wings so silent they create no wake. Others, like falcons, slice through the wind at incredible speeds, but still rely on gentle shifts of wrist and feather to steer. Each movement is tiny, but in flight, tiny is everything. So what about us? Humans can't feel air the way birds can, but we built machines to slow it down for us. High-speed cameras, computational simulations, wind tunnels, and smoke lines, all to study what happens in the blink before lift. Because understanding flight means understanding not just motion, but delay, reaction, adaptation. A wing doesn't force its way into the sky. It learns how to hold the pressure difference just long enough to rise. That takes timing. That takes grace. Even a Boeing jet, massive and loud, relies on these same principles as the quiet kestrel. Its wings are curved, its body shaped to manage drag. Its flaps extend at takeoff and landing, to adjust surface area, all of it in conversation with the air. It's a dialogue in slow motion, one that continues even while you sit inside, reading a book, forgetting you're flying. But the air has not forgotten. It's flowing around every surface. It's pressing against every angle. It's holding you up. And so much of it depends on timing. When to tilt, when to climb, when to yield. It's like a waltz with currents, with density, with invisible partners in every direction. And in this slow motion view, you begin to see flight is not conquest. It's choreography. You're not breaking the sky. You're dancing with it. This perspective changes everything. It reminds us that the world is made not only of objects, but of forces, not only of speed, but of softness, that behind every plane in the sky is a ballet of moving parts, hidden decisions, and slow, deliberate grace. We tend to think that flying is about engines, but before the engine, before even the thrust, there is air. There is shape. There is the whisper of wind against wing. And if we listen closely, if we slow it down, we can hear the very first breath of flight. And maybe now we're ready to listen more closely to the thing that first made flight possible. Not just air, but motion through it. Not just lift, but what pushes us forward into it. Because somewhere beneath this slow, measured rise, there waits a fire waiting to roar. The sky is not still. It breathes. It shifts. It dances with invisible tides. A plane moves through this shifting sea, not like a stone through water, but like a boat across waves, lifted, tilted, tugged in unseen directions. And yet, when you look out from your window mid-flight, the wing seems calm. The sky looks smooth. The cabin feels still. But that stillness is carefully kept. It is earned, maintained, balanced. Every second, every breath. This is the story of how a plane stays steady. Not just how it flies, but how it resists the wobbles, the dips, the rolls, the spins. How it finds poise in a world of invisible winds. Let's begin with a picture in your mind. A plane in the air, suspended like a swallow gliding above a field. There are three directions it can turn, and each one wants to pull it off course. First, there is pitch, the nose tipping up or down. Then, roll when one wing dips and the other lifts. And finally, yaw, a turn left or right like a boat's rudder, cutting the water. These three axes are always present, intertwined like the threads of a braid. And to stay steady, a plane must learn to balance them all. To manage pitch, there is the horizontal stabilizer, a small wing at the tail. It looks simple, but it's a quiet genius. When the nose begins to rise too much, the stabilizer pushes downward, pressing the tail down, tilting the nose back to level. When the nose drops, it eases up, letting the plane lift, like a hand behind your back. When you stumble forward, not to stop you, just to steady. Then there's roll, that delicate dance between the wings. To control it, Planes use ailerons, small flaps on the outer edge of each wing. When one aileron tilts upward, its wing loses a bit of lift. The other tilts downward, gaining lift. The plane rolls, not from brute force, but from asymmetry, from the quiet imbalance of lift across a span. It feels like tilting your arms as you run through wind, a simple lean, and the world turns. And for ya, there is the rudder, placed on the vertical fin at the back. Like the tail of a fish, it sways side to side, guiding the nose. Not for big turns, but for alignment, to keep the plane from slipping sideways, to keep the nose pointing forward, even as the wind tries to twist. These three controls, elevator, ailerons, rudder, are the fingers of the pilot's touch, and with them, the sky becomes negotiable. But human hands are not enough, not always. The sky shifts too quickly. A gust here, a thermal there. So modern planes carry something more: gyroscopes, sensors, stability systems, artificial intelligence, quietly reading the world. It senses a tremble before you feel it. It adjusts a wing before you drift. It's called fly-by-wire, a digital nerve system connecting the pilot's commands to the plane's responses. No longer rods and pulleys, but signals, currents, whispers of electricity, and always feedback. The plane talks back. It says, "This is what I feel. This is where I tilt. This is what the wind is doing beneath my belly." Staying steady is not stillness. It is motion, perfectly balanced. It dance on shifting air. Even the shape of the plane helps it stay aligned. Wings are slightly tilted upward from the body, a design called dihedral. When the plane tips, one wing dips, and its lift increases, nudging the plane back upright. Self-correcting cradle in the sky. The fuselage, too, is shaped not just for speed, but for stability. The placement of engines, the weight of cargo, the balance of passengers, all considered. Because the center of gravity must align with the center of lift. If they don't, if the plane is nose heavy or tail heavy, then even the sky cannot keep it balanced. This is why load planning is as much an art as engineering. Why even the bags beneath your feet have a place they must belong. And when the wind shifts, as it always does, there is the autopilot, a system not of sleep, but of awareness. It holds the course with more precision than a human hand. It corrects not once a minute, but dozens of times, each second. Tiny nudges, whispers in metal, a continual return to balance. It frees the pilot to look forward, to think, to plan. Because steadiness is not only about the moment, it's about readiness. Even birds know this. Watch a hawk in crosswind. See how it angles its wings, how its tail shifts like a rudder, how it holds its head steady while the body moves beneath. They are masters of dynamic stability, the kind that doesn't freeze motion, but flows with it. Plane must do the same, because turbulence will come. The sky is not a constant. It moves with heat, with pressure, with the pull of mountains, and the echo of cities. But steadiness doesn't mean resisting all change. It means responding gracefully. It means being aware of where you are tilted and returning, not by force, but by feel. And when done right, this dance becomes invisible. You, the passenger, sip your tea, read your book, look at clouds, and think of nothing. And that, in itself, is a miracle of design. Stillness, in motion, balance, in speed, softness, in steel. And as the plane rides the long blue path, it does so by negotiating with every whisper of wind, every shift of sky. Because staying steady isn't about being unmoved. It's about always knowing where you are in the flow. And maybe, just maybe, that's not only how flight works, but how life works too. To stay steady, you don't freeze. You feel. You respond. You balance the tilt without resisting the air. And just ahead, as we follow the wake of this balanced journey, comes a moment when the sky no longer holds us, when the descent begins, and the plane, so steady in flight, must now learn, fall with grace. Up there, where clouds drift like quiet thoughts and light bends across horizons, the sky is not just blue, it is mathematical. It is a vast blackboard of invisible ink where equations draw themselves in vapor trails and wind shear, in lift and thrust, in balance and fall. The sky writes equations, whether we watch or not, and a plane, that slender machine of metal and breath, must learn to read them or be swallowed. Because flight, as dreamlike as it seems, is bound by laws etched deep into the fabric of reality. Every motion, every tilt, every change in airspeed is a number. Every climb, a calculation. Every glide, a graph unfolding. And behind the gentle hum of engines and air are the truths that the sky whispers in the language of physics. Let us listen for a moment to that whisper. It begins with Bernoulli, whose name glides through every textbook like a gust through trees. His equation, simple in form, profound in meaning, tells us that pressure drops when speed increases. Air over the curved top of the wing moves faster than the air beneath, and so the pressure above is lower than the pressure below. This difference, this invisible hand, lifts the plane. An equation lifts you. An idea becomes force. But that is only one story. In the book, the sky is writing. There is also Newton, the quiet giant, whose third law murmurs. For every action, there is an equal and opposite reaction. Thrust pushes air backward, and the plane is pushed forward. The wing pushes down on air, and the air pushes up on the wing. It is a partnership, not a conquest. The sky doesn't give way. It responds. And so, flying is not defying gravity. It is negotiating with it. It is proving, with every equation, that motion is a balance of forces. Next, the sky writes about drag, the air's resistance to being moved aside. It writes in swirls and wakes, in the tug of molecules against skin and metal. Drag grows with speed, like a protest, growing louder as the plane pushes harder. There is an equation for that too, the drag equation, with its neat constants and squared velocities. Equal 1, 2, 2, B equal 2, 1. V, 2, C, B, A. It looks cold on paper, but in the sky, it feels like breath on the wings, pulling back as you surge forward. Lift has an equation too, equally elegant. Equal 1, 2, 2, L equal 2, 1. V, 2, C, L, A. See the pattern? Speed squared, area, coefficients born of design. The same air that resists can also lift. It depends on shape. It depends on angle. It depends on how well the plane reads the sky. Even the angle of attack, the tilt of the wing into the wind, is an equation waiting to be solved. Too shallow, and there's no lift. Too steep, and the air separates. Turbulence blooms, and lift vanishes. A stall is not a failure of engines, but of mathematics. The equation goes unsolved. The sky denies lift. And so, flight is a constant balancing of values and variables. Engineers write these equations before planes are born. Pilots solve them in real time with hands and instincts. And onboard computers calculate them 1,000 times per second, because the sky is always writing. It changes the values. A warm front arrives. Air becomes thinner. Altitude climbs. Pressure drops. Rain begins. Drag increases. The equation adjusts itself. The plane must adjust too. Think of Reynolds numbers, those strange, silent indicators of flow type. They decide whether air clings smooth to a surface or breaks into chaotic eddies. Low Reynolds, smooth, quiet flight. High Reynolds, turbulence begins. Engineers whisper these numbers into the shape of wings, into the design of fuselages, into the edges of rudders. Because numbers tell us how the sky will speak to the plane. Even Mach numbers, ratios of speed, to the speed of sound, matter as the plane nears the edge of sonic possibility. Mach 1 is not just a number. It is a boundary between whisper and bang. Below it, air behaves gently. Above it, shock waves bloom. Equations crack into new forms. And still, the sky writes on. There is weight, the ever-pulling hand of gravity. There is thrust, the promise of motion. There is momentum, mass in motion. There is angular velocity, centripetal force, torque, vorticity. A plane in a turn is solving for all of these at once. As it banks, the lift vector tilts. Part of it still opposes gravity. Part of it curves the path. The pilot must increase lift to stay level. An equation whispered into the control stick. The autopilot calculates and obeys. And in all of this, there is beauty. There is a kind of poetry in knowing that behind every movement of wing and rudder is not magic, but math, not mystery, but meaning. Formula suspended in blue air. The sky does not care if we understand. It writes anyway. But when we do understand, when we trace the numbers that arc invisibly above our heads, we get to join the authorship. We fly not just through the sky, but with it. We stop being strangers to the wind. And so, from the earliest gliders to supersonic jets, our journey has been one of listening to the sky's equations, of translating lift into numbers, of turning pressure into propulsion, of understanding what the birds have always known, that the sky is not free, it is governed, and to move through it is to speak its exacting language. And maybe, as you look up at contrails, carving white curves through blue, you'll see more than motion. You'll see math. You'll see how velocity and mass, force and resistance, lift and drag, all collaborate in quiet concert. Like notes in a score, we've only just begun to play well. And just ahead, in our next chapter, we'll see how the dream of equations becomes the daring of flight itself. Because math can give us the rules, but it takes courage to leave the ground. They do not flap, as you might think. They glide, they tilt, they lean into silence and fold the wind like origami. A bird, midair, is not just flying, it is sculpting invisibles, threading unseen rivers of moving air with muscle and instinct so refined we barely understand it. When the hawk spirals upward without a single beat, that is knowledge. When the swallow twists mid-flight to sip from rain, that is calculus with feathers. Because birds do not simply move through the sky. They know how to use it. They shape it. They press against currents we do not feel. They surf thermals that rise like ghost ladders. They fold the wind. To fold, not in the sense of bending paper, but in the deeper way, to tuck, to harness, to reshape energy without wasting it. Let us watch closely, not just to admire, but to learn. Because in the wing of a bird is the blueprint of flight itself. We think the sky holds them up, but no, they hold themselves against the sky. Each feather is part of an orchestra of motion and memory. The outermost ones, called primaries, twist and separate like fingers in a breeze, controlling the fine details of lift and direction. The inner feathers, secondaries, keep the air beneath steady, smooth, like the glide of thought across a pond. Together, they create a lifting surface, more dynamic than any machine. A bird adjusts its wing shape in real time. It can curve its wing, increase camber, that subtle upward arch that invites lift. It can pull its wings in, tuck them like secrets to reduce drag. It can tilt them for a stall, a dive, a quick escape. No human aircraft can match such fine-tuned control in a single flap. This mastery begins in the bones. Birds have hollow bones, not to make them fragile, but to make them light. Strong struts with air inside. Less weight, more lift. The keel, a thick ridge along the breastbone, anchors massive flight muscles. Flex, pull, recover, and the wings rise. But again, it is not just power. It is precision. Look at a falcon in a stew, dropping from the sky at over 200 miles per hour. It folds its wings back into a pointed dart. It lets gravity speak, but never in chaos. The tail adjusts, feathers splay, micro corrections made without thought. It is speed and grace, not despite physics, but because of it. And in gliding birds, the albatross, the condor, the stork, we see another kind of genius. Dynamic soaring, they call it. The bird reads the wind gradient, where slow air meets fast above, by dipping down, then arcing back up. The bird steals speed from the difference. No engine, no flap, just strategy, just folding the wind into useful momentum. Even turbulence, for a bird, is not a threat. It is a tool. Wing slots, gaps between feathers, allow air to move without stalling. These tiny adjustments create micro-vortices that help keep lift alive in uncertain flows. It is like breathing in a storm and knowing which breath to hold. Some birds bend the wind for others. A goose in front takes the burden. The others ride the swirling updraft off its wings. This is formation flying, and it saves energy for the whole flock. Every V-shaped journey across continents is a choreography of shared aerodynamics. They trade places, rotate the lead. They know when to push, when to rest. We learn from them. When planes fly in tight formation today, reducing drag and saving fuel, they are echoing the wisdom of migrating geese. And then there are owls, ghosts of the forest, whose feathers are edged with softness. They do not fold the wind, they erase it. Their flight is silent. They have evolved fringed wings that scatter turbulence, removing the whoosh that prey might hear. It is stealth, born not of machines, but of natural design. Can we build wings like theirs? We try. Engineers study the way feathers flex. They build morphing wings, panels that shift in flight like bird plumage. They design winglets, tiny vertical fins, at the tips of airplane wings that reduce vortex drag, just like a soaring eagle's splayed feathers. They borrow from falcons and starlings and swifts. They build robotic birds, not to mimic flight, but to understand it. Every laboratory with a wind tunnel owes its purpose to birds, because before equations, before simulations, before jet engines and aluminum skin, there were wings, feathered ones, tested in trees, across cliffs, over oceans. Millions of years of biological experimentation. And what did they discover? That the sky does not give flight for free. It must be shaped, felt, folded, again and again. So the next time you see a crow shift its wings midair, or a pigeon turn sharply between buildings, or a gull hover just above the waves, You are watching ancient physics written in movement. You are seeing how the wind can be not just opposed, but partnered with. And as you stand beneath that invisible ceiling called atmosphere, remember, long before we measured lift, named drag, calculated thrust, they were already there, flying, folding the wind, writing the first language of flight in feathers and bone. We only had to watch closely enough to understand. Falling is not always a failure. Sometimes it is an agreement between gravity and grace, between motion and surrender. Not every descent is a collapse. Some are chosen, some are controlled, some are beautiful. You have seen it, a leaf loosed from its branch, spinning softly to the ground. You have seen a feather drift sideways in a hush of air, or a skydiver suspended, not falling like a stone, but floating with arms wide, and time slowed. This is falling gently. But how? How can something drop and yet not plummet? What are the rules of a soft descent? It begins with air. Though invisible, is not empty. It is a sea of molecules, resisting motion like a hand brushing water. Anything that falls meets this invisible sea. It slows, it dances, it negotiates, and in that negotiation comes the magic. It's called drag, not as an enemy now, but as a partner. When you fall through air, drag pushes back. It says, I will not let you accelerate forever. Eventually, you reach an agreement, a constant speed called terminal velocity. No faster, no slower, just balance. A falling skydiver, arms and legs wide, can slow their fall from a deadly plunge to a gentle float. The shape of the body creates surface area. Surface area invites drag. Drag resists the fall, like opening a parachute with your own limbs. Speaking of parachutes, they are nothing but glorified air catchers. Fabric, shaped like a dome, designed not to stop descent, but to slow it into safety. The physics is simple, yet the feeling is profound. You fall with a parachute, but you don't crash. You drift, you hover, you land like a whispered thought finding ground. This is what engineers call deceleration through resistance. But what you feel is surrender with grace. Birds do it too. Watch a pigeon land on a rooftop. It flares its wings, fans its tail, tilts its body against the air. It is not falling like an object. It is balancing force against force, drag against gravity, lift against motion, weight against wing. Even insects have mastered it. Dandelion seed, with its tiny white parachute, floats through the wind like a dream with no urgency. A spider releases a silk thread and sails through the sky. A miniature paraglider, a quiet aerialist. Nature does not fear falling. It prepares for it. Humans, too, have learned. In spacecraft, re-entry into Earth's atmosphere is not a crash. It is falling gently managed. Capsules are shaped to use drag as a cushion. Each shield burned with fire. Yes, but behind them is the soft science of slowing down. Once slowed, parachutes bloom like flowers in reverse. Some landers use retro rockets thrust downward to fight descent. Some use airbags, bouncing softly on alien soil. Even on Mars, we fall with care, because falling, when done right, is not a failure, but a final step in the dance. Think now of gliders. They are aircraft without engines, born to fall, but trained to fall well. A glider does not stay aloft by flapping or pushing. It rides the slope of descent like a skier on an invisible hill. It trades height for distance. It folds air beneath its wings and slips forward in a long, slow slide through the sky. It may fall, but it falls far, and with skill, a glider pilot can find thermals, pockets of warm, rising air, and use them to gain height again, to fall, then rise, to descend, then dance. Even paper planes, with no systems, no sensors, teach us something here. Folded carefully, thrown gently, they fall in slow spirals, not because they are strong, but because they are shaped to listen to the air. The air is always speaking. It offers resistance, offers lift, offers rest. If we shape ourselves to meet it, we fall differently, not as failures, not as broken things, but as listeners, as participants. The design of falling is not just downward, it is also outward, forward, sometimes even upward, because falling can be curved, it can be softened, it can be chosen. And when we design flight, from wingsuits to Mars landers, from drone deliveries to gliding squirrels, we return again and again to this question: how do you come down without breaking? And the answer, always, is in shape, in timing, in patience, in the partnership between motion and medium. It is in the way a pilot flares the nose just before touchdown, the way a leaf tilts to find more drag, the way a child jumps from a swing and lands, knees bent, arms open. It is in trust. The ground is not an enemy, it is the goal. We are not escaping gravity, we are using it, redirecting it, asking it to carry us down like a lullaby. So fall, if you must, but fall like a feather, like a glider, like a thought that knows where it's going. Let descent be a kind of flight. Let the air catch you in its invisible hands. Let the end be soft. And as you rest here, on this new surface, on this quiet earth, you might wonder, if falling can be shaped so gently, what else can be? What else might we control? Not by force, but by form? Because ahead of you is another question, one whispered in the space between wind and wings, a question about shape, about curves, about bending air instead of cutting it, about flight that's stable, not just in the sky, but within. You've had the dream, haven't you? The one where your feet lift, not with effort, not with struggle, but with a quiet knowing that you were always meant to rise. Your arms spread, not like wings, but like permission, as if the sky were not a ceiling, but a memory. You drift upward, weightless, slow, and somewhere below, the world softens. You are flying, and it feels like returning. But why? Why is this the dream we carry through centuries, cultures, childhoods? Why, in the silence of sleep, do our bodies forget gravity so easily? Maybe it's because flight is not just a wish, it is a question we never stop asking. Even before machines, before wings of wood and cloth, before lift equations or jet engines, humans looked up and wondered. Birds did it, clouds floated, leaves danced, and we remained earthbound. So we began to imagine Icarus, who rose too high on wings of wax. His story, not just a warning, but a desire wrapped in tragedy. The angels of sacred texts, always arriving from above, always winged, always transcendent. The gods who flew, the heroes who leapt, the dreams of feathers, of rising, not just escape, but transformation. And still, we dream. When you fly in your sleep, it is not like in planes. You are not strapped in, not staring from a window. You simply lift. You move without sound, without force. You glide because you believe. In dreams, the laws of physics loosen their grip. And yet, your mind invents new ones. You may not know the word for lift, or drag, or thrust, but your body feels them. You dip and soar in perfect balance, guided by something ancient and quiet. In this floating world, flight is not built, it is remembered. And still, the science lingers. Even here, inside this sleeping story, you carry everything you've learned. That lift is born from pressure's difference, air slipping faster over the curved top of a wing. That wings work not by magic, but by patience, shaping the wind instead of fighting it. That the air itself is a substance you ride, a partner, a river of invisible current. You remember that birds tuck their feathers to fall on purpose, and planes must bank to turn. That gravity never disappears. It is simply negotiated with motion. Even your dreams carry this knowledge like soft feathers stitched to your thoughts. The science of flight is not separate from your dreaming. It is what makes the dream feel real, because somewhere in you, you know how flying works. You've learned that thrust must overcome drag, that every rise requires a push, that the air resists but also holds. And yet, despite all that effort, all that math, the thing you feel when you fly is peace. Why? Because flight is quiet at its core. Even the loudest engines are chasing a silent goal: to be free of friction, to stay steady, to touch the sky without disturbing it. Maybe you dream of flying because your body longs for stillness that moves. Maybe lift feels like love, support you don't have to ask for. a presence beneath you that says, I've got you. And maybe the sky feels like return, not escape, not above, but back to something your bones remember, even if you've never left the ground. When you dream of flying, you dream of letting go, of trusting the air, of moving with grace instead of force, of being in balance with the invisible. That is the final gift of flight, not speed, not distance, but surrender. The sky doesn't ask to be conquered. It waits for your understanding. Now, as you lie here, you're breathing steady. You might feel that pull again, a soft upwardness behind your ribs, a part of you ready to lift, not to leave, not to run, but to rise. And you can. Because you understand now. You've walked through the physics of flight, not through diagrams, but through feeling. You've touched the invisible forces, felt how air curves, how wings listen, how lift is born from patience in shape. You've traveled through thrust and drag, through balance and falling, through wings of birds and dreams of machines. And now you arrive here at the place where flying and dreaming become the same thing. Because what is flight but the permission to believe in something greater than gravity? You don't have to be asleep to float. You don't need feathers or fuel, only wonder. You already have the shape that wants to rise. You already know the balance that lets you glide. You already carry the sky. So next time the dream returns, when your toes lift and the rooftops tilt below, know that you are not escaping. You are remembering. You were always meant to rise. And even when you wake, the sky remains open. Thank you for floating with me tonight through the skies of thought and the still air of dreams. This was the Dreamy Physicist, where science softens and wonder takes wing, where wings remember birds, and even gravity learns to be kind, where you are never too grounded to rise. I'm so grateful you've been here, listening, imagining, and drifting through the quiet magic of how things move. And now, may your thoughts settle, your breath slow, and your heart feel a little lighter than it did before. Good night, gentle mind. You were always meant to rise.